And actually, the university's got a thing where you're supposed to record so many classes and put them up on the VLE every year or something like that. I think I beat the campus requirements by myself, just that there. Well, it's so easy with the software. All right, where I left off was I got through the math functions, and I really didn't get very far into that. And as I said, I'm planning on meeting next week. Hopefully, I can still complete, even though I missed Monday. That's there. So let me just jump in here. Where's my mouse? Right there. Okay, I know. Oh, my hand's on the mouse. That's there. Okay. Did I mention I got some brain damage at there? So, I can't find the mouse while my hand's holding it. So it's, it's like people that walk around like this, and looking around their house looking for their glasses. I mean, my wife does that all the time, and I keep reminding her that she doesn't have the brain damage in the house. I do. That there. So, okay, I kind of last time I talked about these basic math functions. They should all be familiar with to everybody. Everyone in this class, I assume, knows what the inverse sine is, or the arctangent, or the arcsine. That there are log base 2, log base 10. Right there. This actually doesn't have on its graph the log base 2, but it does have it built into that there. So it does do base 2 logs, and base 2 logs are common in computer science problems, not in necessarily regular engineering problems. So, okay, what happens if I type something in? That there. And if I type in the word problem 1, MATLAB has to check to see what do I mean by problem 1. So the first thing it checks is see whether or not it's a variable name in the current workspace. Now we've got the workspace there, and if I type in the name of a variable, it will return back the value of that there. If not, it will check to see if it's one of its own commands and executes that there. So that there. Now this makes kind of for an interesting dilemma, is that key names such as cosine, for example, could be assigned variable names right there. And let me, okay. Bring up MATLAB and kind of show you what I mean real quick right there. And I'm going to run MATLAB, even though, like I said, I've got a little bit of an assignment. I'll post it on Facebook at the end of the class that I'm not going to have you turn it in, but I might have you turn it in just simply for just kind of a check off. I won't grade it, but just simply that there. But, for example, I could say cosine equals 52 right there. So if I type cos, it comes back 52. Now cosine is a function right there. So y is equal to cosine, and I'm just going to say pi right there. And notice that cosine no longer works right there. So that's something you've got to be aware of with MATLAB. If you use a reserved word in C, you get a warning saying you've used a reserved word or a syntax error. If you use a reserved word, now I'm having trouble with my speaking. Actually, that is related to my other issues. My language processing was also damaged with my motor skills. So sometimes my pronunciation gets weird. But if you use a reserved word in C, the compiler catches it and that there. So if I do a clear, now clear now clears out that there. And I could say here that here, now it works because I cleared out cosine from the workspace. That there. So this runs into a little bit of a problem here, is that when you type in anything, whether it's problem 1 in this example or cost, in the example I did, the first thing it's going to do is see if it's a variable and display its value. So next it checks to see whether it's one of its own commands or library functions right there. So if you override a library function or a reserved word with a value that you want, for example, pi is equal to 59, right there, and I type pi, it's 59. If I clear it and I type pi, it gives me the right value. So it allows, MATLAB is got a little bit of a quirk there. It allows you to overwrite built-in function names and variables right there. So it's just something you need to be aware of. That there. So it checks to see if it's one of its own commands and executes it right there. If not, it looks in the current library, and it looks for something called a problem1.m. And then we're going to write .m's. .m's are script files, or they're program files right there. And if we want to write a program in MATLAB, we will put it in a .m file. And .m files are not like .c files or .vb for Visual Basic, that there, or .r if you're using R, .v if you're using VHDL, although VHDL is a hardware description language, it's not a programming language. But it's just it's a subscript that denotes MATLAB files right there. Now, Octave will run MATLAB files of any of the complexities that we'll run in this class. So, if not, it searches the directories in the path order looking for a .m file with that name. And if it does, it executes it if found. So that's what happens right there. And this just repeats the same thing. I'm going to skip this particular part here. This is getting back to and I talked last time about the DOS and Linux command line type commands right there. Actually, most of you probably won't do it this way. If you want to, for example, right here, current folder right here, you can right here along the top, normally you have find files, open, new script, new, clear right there. But you can tell it to right here, go up to the current directory, find a directory, right here, create a new directory. I think there's a new directory right here. New folder right there. New directory here. I can rename it. Rename it program or M files right there. I can right click this and add to path right there, selected folders and subfolders, and that's now part of the path right there. That's the easier way than going through and remembering these commands. It's very much like Windows Explorer if you do it in the directory window. Old people like me might do it this way. I grew up with DOS. I grew up before DOS, actually. I was in college when DOS came out. DOS came out originally in 1978, 79. My first laptop computer that came with DOS 1.0. Actually, DOS probably came out later than that because that came with DOS 1.0, and that was in 83. So that tells you how long these commands have been around. A lot longer than you've been alive. Right there. And these are the kind of commands that we used back then. Actually, DOS 1.0 did not have directories. That was the first version of DOS did not have directories. That didn't come out till DOS 2.0, right there. So, okay. Again, display the current directory. All this stuff here, don't worry about it. Again, don't worry about all these commands. If you want to manipulate things around the directory, just now you may have to make sure that the directory window is shown, because here I've got the command history. I've also turned off on the layout right here. Current folder is right here. You could turn that off. So under layout, current folder right here, notice that the workspace, oh, the workspace is shown, but it's right there. Okay, it's small enough there. So that there. This is my normal workspace, by the way, I should point out. I have the current folder is one window, the command history, and again, I can come back here and double click on any command and re-execute it right there. And these are right there. Again, I can double click on any one of these and change its value. Actually, you have to double click on the matrix. And I can change its value right there. So, right. So again, all this discussion right here, both these slides here actually get into how to manipulate your way through the directories right there, and using the command window. And I'm saying, for those of you that grew up in the generation after using command, command prompts and command windows, it's probably easier for you just to use the directory window right there, current folder. Okay, you can do a graphics window, and I did that right here. Now notice that we've got here where we've put in some labels right here. We'll do some examples of that here in a minute right there. But one of the things that MATLAB does very easy for us is plot right there. And here. So again, you can also use the mouse to get points. I rarely use the mouse to get points. I don't know why people would do that. Generally, if you want interactive programs, you would point to something, and then your software will then tell you what the value of that is. I typically have always used MATLAB as basically a super calculator for doing calculations or run that there. I haven't written that many interactive programs in MATLAB. Some people do. I just don't. That's just my nature. We're not going to get into that in this class on how to write interactives, but there's a command called XY that gets the input of the mouse and returns that in a vector right there. And you can say X comma Y equals G, and I have to remember that G input and right there. And I forgot the equal sign again. And I don't have N. I'm not sure if that works. And again, you see if I click the mouse, it tells me the value of X and Y right there. That gives me the graphics window. I can come here and I can just click the mouse anywhere right here. Here I'm going to do it about 0.1.1 right there. And you'll see that it's 0.0991 and 0.0953. So I can read the mouse input right there. Now notice that it only allows me to do it once right there. in that command right there. And the one is, whatever mouse that you're input that you're dealing with right there. So again, I don't that there. G-text allows us to place text with the mouse. That's kind of an interesting thing right there. Again, I can do make sure I get this right. G-text. And I come up here and if I click on the mouse, it just places the text at that location. Right there. Again, I don't use that very often, but that might be useful if you wanted to highlight reports. In other words, this is the point that I wanted to show you or whatever right there. I'll be real honest, I usually copy and paste my plots into Word and then do the highlighting inside Word right there. That's just, because I can copy, there's a control print screen and right there where you can grab that there. Again, these are just basic things on the plots right there. Okay, our plots commands right there are plot, and we give it two arrays, an X and Y. X is on the X-axis and Y is of course on the Y-axis right there. Generates the plot of array versus the X on a rectangular axis. We can place a title on our plot. We can label each one of these right there. And these are additional commands. So if I wanted to plot, and there's probably an example right here. Oh, okay, this is getting into solution equations. If I want to plot, let me just go through and do an example. X is equal to 0:0.01 2 times, what did I do here? I hit the wrong key. X is equal to, open my bracket to start an array, start at 0.01 between each of the points, and we're going to end at 2 times pi. Close our bracket right there. So now that generates an array. Now we're going to say y is equal to 5 times the sine of x right there, right here. And we can do a plot x comma y right there. We can come back to this right here and we could say title sine x. I think that's right. Oh, it wants single quotes. We go back to our plot. Notice that I put the title on it there. We can do again X label and Y label. And I always misspell these because it's X label. And what's going on with my hands here? X data. I'm just making it more than one word, just simply to right there. And You look back at the plot, and you can see I've added the labels there, right there. So we can also, and I'm not going to go into great detail with it there. We can also add more plots to it. We can also change colors. We can vary the widths of our lines. But as you can see, plotting with MATLAB is easier than probably about any other language you can get at, with maybe with the exception of Excel, where Excel, yeah, actually I think this is easier than Excel, to be honest with you. I don't want to show you how to do it with Excel because then you'll get confused, right? All right, so these are some of the basic that they're, and the textbook, thought I had the book open. Yeah, I do have the book open. Book goes into more detail on arrays. This is actually not a bad book. Again, here we show a plot where we have three different ones right there. Let me just copy that one right there and use that as an example to show. Oh. And I'm going to say Z is equal to 5 times right there. Comma Z. Oh. I gotta say X to Z again. Right there. So now if I look at the plot, you can see that I've got two different plots here. But you have to list X, Y, and XZ so that it knows right there. Now, if I change things around, I can have different X values if I want to in this particular case, which would make it somewhat confusing. You would end up with two sets of legends on the bottom right there. And again, I can also turn on a grid. Okay. Grid, yeah, just grid. And you see it turns on. I don't know if you can see the grid there. It looks like you can see the grid right there. So again, I don't want to spend a lot of time. The book actually goes through some more examples right there. We can set up data markers right there. Here we've got XY plus right here. And it gives some example. Now we're going to get into linear equations. Now, what a linear equation is, right there, is if we have, let me just look at two equations and two unknowns. I've got an XY coordinate, and I've got one equation, X is equal to 3y plus 2, for example. It's going to go through the point 2, and it's going to have a slope of 3, something like that, right? Actually, that's X. It's that way. That's it. Regardless, it's a straight line. And then if I have another equation, x2 is equal to 4y plus 4, for example, it may have something like that. And the two cross. You have one solution between the two of them, right there. And that's a system of two equations, two unknowns, right there. Or yeah. Right there. So when we look at and I thought I had the Oh, yeah, here it is. Right there. Here we've got a system of equations with three unknowns right there, x, y, and z right there. And so whenever you have three equations with three unknowns, you can either, you may have one solution, two solutions, no infinite solutions, no solutions. I mean, you may or may not, there may or may not be a solution to this system of equations. That there. So, but in most real cases, and we're talking electrical engineering, I'm going to use a case of a three-loop circuit with three loops, three currents, or three voltages, and three unknowns right there. So whether we're using Kirchhoff's voltage law or Kirchhoff's current law, I'm going to use that as an example, and actually that's part of the final project. I haven't posted it yet. That there, I'm going to use one of the ones I used a couple of semesters ago, but change the numbers that there a little bit. But if I have three equations, three unknowns, that there, we should get a value if there is a single solution for x, y, and z. That all three meet the requirements of each and every solution right there. Now, whenever we have a look at linear algebra, we can either write it in this form right here, right there, or we can write it in matrix form right there. And whenever we take, and I did not spend a lot of time with thinking about covering this today, so it may be, I may embarrass myself here, but I'm just going to write three equations, three unknowns. They may or may not have a solution. I don't care. But let's look at the vector x1, x2, x3 right there. That's a vector of three unknowns. Let's look at a matrix here. And I'm going to call this A, B, C, D, E, F, G, H, and I right there. That's a 3 by 3 matrix right there. And that's equal to, and I'm going to say another vector, B1, B2, B3. Now this is a matrix equation. The way that I would write this equation right here, and we're assuming that we have values for these right there. If I want to multiply a 3 by 3 matrix times a 3 by 1 vector, I'm going to get a 3 by 1 vector because I take, and I'm going to use different colors here, I take this row times this column. And that gives me this value right there. I take this row times this column. This gives me this value right here. I take this row times this column, and I get this value right there. So in this particular case, A times x1 plus B times x2 plus C times x3 equals V1, right? D times x1 plus E times x2 plus F times x3 equals V2. G times x1 plus H times x2 plus I times x3 equals V3, right? Does everyone see what I did? And again, I'm assuming you had some introduction to linear algebra before, so I'm hoping this is review right there. So if I take a circuit, and I'm just going to take a relatively simple circuit, and I'm just going to put some values in here. 12 ohms, 6 volts right there. I'm going to put a plus sign right there. 6 ohms, 8 ohms, plus 18, 3 ohms, and again I'm just picking random values. 4 ohms. I'm going to, for sake of argument, put this one backwards. 24 volts right there. And I'm going to say 6 and 12 right there. So this is a typical 3-loop equation you should have seen in your freshman circuits course, right? That's there. And I can write 3 loop equations around here. I1, I2, I3, right there. Now, I normally draw all my loops clockwise and within the circuit. There's no rules on loop equations where you draw the loops. They can be, some can be clockwise, some can be counterclockwise. The only rule is that every component in every branch is included. If I wanted to, I could draw a 4th loop. I'm not going to include it. I could draw a 4th loop around the outside right here and call that I4, for example. I wouldn't be wrong, but that would just be a redundant loop. I wouldn't need it to solve the problem right there. So, okay, getting back to my circuit right here, I can then go through and I can start writing my loop equations right there. And I'm going to start at this point here, and then I'm going to start at this point, and I'm going to start my point. And I'm just going to write the drops as I go around that there. So I end up with minus 6 volts plus 12 volts times I1 plus, or 12 ohms, excuse me. Right there, I'm just going to, for sake of argument, I'm just going to leave the 12. I'm going to drop the ohms right there, just simply right there. Plus 6 times I1 plus 8 I1 minus I2 plus 18 equals 0 right there. And we'll reduce these equations here in a minute right there. And I'm going to finish this example, so it'll probably take me close to 1:30. So that there. Loop 2, again, I'm going to have minus 18 right there, plus 8 I2 minus I1. Oh, call it the curve. Okay, then let's see, minus plus 8 minus that there, plus 3 I2 plus 4 I2 minus I3 minus 24 equals 0 right there. That's loop 2. Loop 3, 24 plus 4 I3 minus I2 plus 6 I3 plus 12 I3 equals 0. Okay, right there. So those are our three loops right there. You know, then we reduce this, and what we wanted is, and I'm going to, before I go too much further, I'm going to this is my hand that's not cooperating. Yeah. We'll just come back to it. For whatever reason, my hand keeps pulling off the paper right there. So, okay. So what we're going to have to do is we want it in a form right there, and let me just put it on the next page and then I'll come back to it. We want it in the form of, and I'm going to call it R11 I1 plus R12 I2 plus R13 I3 equals V1, something like that right there. R121 I1 plus R22 I2 plus R23 I3 equals V2, R31 I1 plus R32, is that right? Yep, plus R33 I3 equals V3, right there. So that's the form we want it to be in, right there. And again, this should all be review right there. So let's look at this right here. And what we've got in terms of I1, and I'm just going to put I1 by itself right here. And I'm going to put a bracket right there next to it, right there. And actually, we should do it the other way around where it matches the drawing right there. So we're going to put a bracket here. We're going to put I1 right there. Plus another bracket, I2 plus another bracket, I3, and equal right there. Well, let's just go through here. I1, I've got 12, I've got 6, and I've got 8. So I just add those up. They're all positive, and I just add them up. So that's 18 plus 8 is what, 24? Is that, or 26? Does that sound right? Is my math right there? 12 plus 6 is 18, plus 8 is 26. So I just write a 26 right there. And I just get that from the I2, I've got one value right there. I2 only shows up once in the first equation. And it's got a negative 8 in front of it right there. Because if I multiply 8 times I1 minus I2, I get 8I1 and negative 8I2. So I could put a negative 8 right here. I3 doesn't show up anywhere at all, correct? So I just put a 0 right there. Again, this is all supposed to be a review, but it's probably one of those subjects that it doesn't hurt to review again a couple years after you've seen it the first time, right? You probably haven't used this much. Constants, I've got two constants here. I got a negative 6 and a plus 18. You see our two constants right here, 6 and 18 right there. Those are our two. Those represent batteries in our right there. So negative 6 plus 18 is 12, but I have to move it to the right side, so I have to change its sign. So it becomes negative 12 when I move it to the right side. Negative 6 plus 18 is plus 12, but I'm moving it to the right side of the equation, so it becomes negative 12 right here. Right there. That's negative 12. Now we repeat this for the first equation, and I1 appears in the first equation, or second equation. I1 appears one time, and it's got a negative 8 in front of it, correct? Right there. It only appears here. It doesn't appear anywhere else in the equation, and it's got a negative 8 right there. I2 appears 3 times. 8 plus 3 plus 4. So that comes to 15, right? 8I2 plus 3I2 is 11I2 plus 4I2 is 15I2. Plus I3 appears one time, and it's got a negative 4 in front of it. Constants, we've got 18 again, and that's it, right? There's only one 18 there. Right there. And it's negative, so when we move to the other side, it becomes positive. Right there. So 18 right there. We repeat this for the third equation, and I'm just going to jump in there and put the answer. Oh, I forgot to equal 0 there. Right there. Oh, did I think I missed. No. Second equation. Yeah, the second equation is wrong. I made a mistake on the second equation. That's negative 18, negative 24. So this 18 is wrong. I missed this 24 here. So the second equation is wrong right there. So 18 plus 24 is 32, 42. Does that sound right? 42. So I don't know if anybody caught where I missed that 24 there, but I got it there. And I3, I've got 4, 6, 10, 22 I3 equals and negative 24. So those are my three equations and three unknowns right there. So I could, at this point, I could actually come up with a matrix from this right here. And I can say that R is equal to 26 minus 8, 0, minus 8, 15, minus 4, 0, minus 4, 22, right there. I could say V is equal to negative 12, 42, negative 24, right there. So I could then say that my expression is R times I equals V, right? Now if I can do this, I can say I is equal to R over 1 times V, right? Because R times R to the negative 1 equals the identity matrix in matrix term. Now, it's the same thing as if you're doing it in algebraic terms and we're dealing with scalar math. But in matrix terms, we have something called the identity matrix that looks like this. 1, 1, 1, 0, 0, 0, 0, 0, 0, 1. and anything times that is equal to itself. So that's the identity matrix. So if I take r times r to the negative 1, I end up with I, which is the matrix equivalent of 1. Right there. And if I multiply the left side, I can also multiply the right side. So I can come up with this matrix r to the negative 1. So I don't know how well this is going to work, but I'm going to right here. I'm just going to go ahead and try entering that in and see if I get a value right there. And I'm going to stop at this point. I've got more stuff to talk about on this subject, but I'm going to, I got a little bit of time. Let me just go ahead and do the example. I'm going to say R is equal to bracket 26 bracket 26 space negative 1 space 0 semicolon. I keep hitting the, and that's my right hand being cooperative. Minus 8, 15, minus 4, semicolon, 0, space, minus 4, 22, close our bracket. And I like to go ahead and let it show it to me so that I see that it looks right. That's there. And it's not right because, oh, no, that's right. My eyes are not right. No, it's not right. Right there. Okay, a few words about this matrix right here. If you follow my discussion where I drew everything clockwise and I stuck within the circles, this matrix is going to be symmetrical and it's going to be non-zero on the main axis in every case. So as I look at this matrix right here, you look on the main diagonal, you'll notice that it's everything on that main diagonal is not a 0. Everything off the main diagonal, as a general rule, is going to be negative. Right there. It's also going to be symmetrical. And that has the nature of linear equation and standard mesh circuit analysis right there. You're always going to end up with that kind of relationship. In about 99% of the case, you probably can find a special circuit that doesn't, but if you look at a normal mesh circuit, it's always going to have that particular type of circuit right there. And I'll talk a little bit about how you could write the matrix straight from the circuit without ever writing the equations. Now, there's a trick to doing that. That actually speeds this process up a great deal, but I'll cover that on Monday right there. So, but there's the R matrix right there. So then we go ahead and we enter the V matrix right there. And B is equal to bracket negative 12 semicolon 42 semicolon negative 24. Close our bracket. That there. Now there's no special rule on the V vector. So I can just simply say at this particular case, I is equal to, and I'll talk about the fact that there's a shortcut that there, but I can see R raised to the minus 1. That's the inverse of R right there times V right there. And that's my current vector right there. My very simple way of calculating the current in a 3-loop equation, three unknowns. Now, if we go back to the book right here, he just gives 3 equations, 3 unknowns, and The only thing he does different here is he gives A right here. A is is 6, 12, 4. You know, right there. The second line is 7, -2, 3. And then the third row is 2, 8, -9. His B vector is 75 and 64. He did that exactly like I did, only I started with a circuit to show where this equation would come from. He's a mechanical engineer, so he may be using some kind of vector drawing in order to come up with this right here. And the only thing he does different is he uses this / right there to say that that solution is B divided by A. And that's a reverse current right there. It's a pre-multiplier for matrices. I just used the R to the -1 just to show that that's what it's actually doing. So I can go back to this here, and I can say I is equal to R/B and come up with the same solution right there. It's a little less typing, but what that's actually doing is finding the inverse of R right there. And I can say K is equal to R divided right there. And that gives me the identity matrix right there. So, but that's how we would solve a system of simultaneous equations. I want to come back to this for like maybe 10 minutes on Monday to hit a few highlights on that there. So, right there. Let me continue on right here. Okay. There are two ways that we could do things. We've kind of hinted on that there, right there, and right there. Or we can write a script file. You can write a script file by run a script file by typing its name. That's there. I can write a script file fairly easy, and I can run it really easy. Let me just give an example of how that's done real quick. Right there. We're going to create a script file, new script, right there. It brings up a blank page like this. And I can say X, I'm going to say X is equal to bracket 0, semicolon, on 0.01, semicolon, 4 times pi, close our bracket, semicolon, y is equal to sine x, semicolon, plot x, y, right there. And I'm just going to save this. Save as, M files, and I'm just going to call it test1, right there. So I'm going to close this. Now test1 is part of my path, right there. So if I just type test1, it should, and why it did that, I don't know. That's interesting. Let me go back and review my test file right there. And did I make a stupid mistake? It's probably not the first time I made a stupid mistake in life. Right there. Oh, I did make a stupid mistake. These are supposed to be colons. Right there. So we save it. We come down here and we type S1 again. And this shows me that I had an error. I didn't put the 0 there. So I come back here and I hit test1. And there it works. So now I don't have to type that. It's now been saved as a file right there. So I can close MATLAB out completely right there. Open it back up. Now it may not work because I may have to add that to the path. See, well, I see, again, in this particular case, it's going to work because it remembered the last path. Right there. But as you can see, I can close it and I don't have to type those commands. And I could go over here and I can bring this up and I can add more to it right there. And I can keep expanding to this. And I can solve a very complex problem and not have to type in all the various variables each time I type it. I can start putting in loops and while loops and things like that to solve more complex. And I can start doing C-like stuff with MATLAB now, with the power of MATLAB. So as we look at, and where is right there. Right there. So as we go through and we look at this right here. So this is right there. We can put comments. The percent sign gives us comments right there. And this is a simple one right there. So here they bring up the editor again. The easiest way to bring up the editor is just say new script file, or you open a script file. So if you go back to MATLAB right here, you can hit open right there, and that opens the files right there. Right there. So right there. Keep in mind, it must begin with a letter. Same rules as any other, don't use any spaces in the file names. It may or may not allow spaces, but spaces tend to screw up Linux-based programs such as MATLAB. So I haven't tried using spaces, but I know Altera pukes all over it. Portis will puke all over it. So right there. Do not get. Oh, I don't know what the heck that is. My phone is up there.
I didn't recognize that. Could you tell me your password?
My phone is doing something weird. Oh. Message for me to call. It's a dentist up there. Again, going back to what I said at the beginning of class, variable names and function names and constant names within MATLAB. If you use the same name, it creates serious issues right there. So if I go back to my MATLAB here, we know that test 1 works, but if I do something like here, test 1 equals 5, right there, if I type test 1 again, it's going to give me 5. It's not going to run my program. So if I do a clear test 1, right there, and I run test 1, it plots my file again, right there. So again, test 1, it's going to look for a variable name first, then the M file, right there. So if you use the name of an M file as a variable, then it's not going to find the M file, right there. Right there. Same name, again, same thing at their syntax. We're not going to worry too much about this. Syntax for MATLAB is actually simpler than C, but and the syntax is actually the same as if you're in the command window. Right there. And again, if you're running your program, it'll flag where the error is, right there. So it's right there. Comment sections, programming styles, right there. It's all same rules as C. I'm not going to spend much time. Input, calculation, output. this gets into program, how we would define our programs. We just went through an entire course on programming. So, you have your inputs where you input the data, you do your calculations, and you output what your outputs should look like. So we have input commands right there. X is equal to input. X, that there, where we can tell it that we want to, right here. So this particular one here is we're telling it that it's a string right here. So again, we can spend a long time on this. I'm not going to dwell on it. As I said, I was going to talk to you about 130, and that's pretty much where I'm at right now, right there. And actually, this is going to be an example of a script file we'll pick up here on Monday, right there. I do have, matter of fact, why don't I have you do this between now and Monday? Go through this script file and test it right there. So, right there, and tell me what you've got right here. So this is a script file. You look in the book for what the solution should look like, but let me just talk up briefly about it right here. Is that we've got an object it's going to fall, input variable final time in seconds, and we're going to calculate T is the array of times in which the speed is computed in seconds, B is an array of speeds, G input, enter your final time. Calculation is right there. DT is we're dividing it by 100 points. We're going to create. Now this particular way, I should point out here, is that this is saying, well, this is the same as what we're doing. We start at 0 and we're telling it we want to do, say, for 3 seconds or 5 seconds. So we're going to divide that by 500 to get 500 points. And our final time is whatever we inputted right there. So we input the final time right there. We calculate G is equal to the coefficient of gravity times time, and that does it for the entire array. Then we plot the array. Now this is going to be a linear array. It's just going to show speed versus time right there. So right there. And that's there. So that's there. And we'll talk about that. I actually am going to shut up at this point right there.